हेलो फ्रेंड्स। आज हम पेरीसाइक्लिक केमिस्ट्री टॉपिक की शुरुआत करेंगे। ये टॉपिक बहुत ही इंपॉर्टेंट टॉपिक है, रिसर्च पॉइंट ऑफ व्यू से भी ये एक बहुत अच्छा टॉपिक है। तो चलिए शुरुआत करते हैं पेरीसाइक्लिक केमिस्ट्री की। सो हम सबसे पहले इसका इंट्रोडक्शन डिस्कस करेंगे, देन सम बेसिक टॉपिक्स रिलेटेड टू पेरीसाइक्लिक केमिस्ट्री दैट नीड टू डिस्कस बिफोर एक्चुअली giving a start to the pericyclic reactions. Okay, after that we will discuss every type of pericyclic reactions, which are electrocyclic reactions, cycloaddition reactions, sigmatropic reactions, and group transfer reactions. And these basic topics that we have discussed after introduction, these will help us for the deeper understanding of each pericyclic reactions. तो चलिए शुरुआत करते हैं इंट्रोडक्शन के साथ। थ्रू एग्जाम्पल वी कैन डिफरेंशिएट, बट वी शुड नो लाइक व्हाट आर द रियल रीजंस कि एक पेरीसाइक्लिक रिएक्शन नॉर्मल ऑर्गेनिक रिएक्शन से डिफरेंट होती है। कोई भी पेरीसाइक्लिक रिएक्शन होती है या कोई भी रिएक्शन है, अगर हम उसको पेरीसाइक्लिक बोलते हैं तो दैट रिएक्शन शुड फुलफिल टू कंडीशन। द वेरी फर्स्ट कंडीशन इज दैट रिएक्शन शुड बी कंसर्टेड. The very first condition is concerted reaction. The second is that reaction should involve the cyclic shift of electron. So what is concerted reactions? The bond breaking in reactants and bond formation in product. If that happens simultaneously, then we can call a reaction is concerted reaction. It means your activation energy barrier lead to the formation of product through the transition state only. There is no intermediate in between, then we can call that reaction a concerted reaction. So in concerted reaction, bond breaking of reactant and bond formation of product happen simultaneously through the formation of transition state, and there will not be any formation of intermediate in between. By combining these two conditions, that pericyclic reaction should have cyclic transition state. Pericyclic reaction should have cyclic transition state. Combining over these 3 points, so pericyclic reactions are concerted reactions first. Second is pericyclic reactions involve cyclic shift of electrons, and pericyclic reactions have cyclic transition state. Now we will discuss the types of pericyclic reactions. 4 major types of pericyclic reactions are there that we need to discuss. Very first one is electrocyclic reaction. The second is cycloaddition reaction. The third is sigmatropic rearrangement reaction, and fourth is group transfer reaction. Let's discuss one by one each type of pericyclic reaction, and now we will get to know how these 4 reactions are different from each other. So in electrocyclic reactions, either a ring is closed or opened at the cost of one pi bond. It means one pi bond will be consumed and your reactant will be turning to a cyclic product. Okay, so this example that I am giving here is 6 pi electrocyclic reaction. You can see how electrons are moving during the course of reaction. How the reactions are moving, that we will discuss when we will discuss the mechanism of electrocyclic reaction. So when a cyclic reactant is converted to the cyclic product, we can call that reaction is ring closing electrocyclic reaction, and the reverse is called ring opening electrocyclic reaction. That means we can say one pi bond is converted to sigma bond. Rather, it is not the true sense to say. Rather, we can say is like one pi bond is consumed and one new sigma bond is formed from the acyclic reactant to the cyclic product. The second type of pericyclic reaction is cycloaddition reaction. So in this reaction, a ring is formed at the cost of one pi bond. So in these reactions, a ring is formed at the cost of one pi bond from each participating reactant. Okay, it means when two reactants are participating in cycloaddition reactions, it means one pi bond from each reactant. That is total 2 pi bonds will be consumed and a ring is product. It means cyclic product will form. You can see the example of photo-induced 2 plus 2 cycloaddition reaction. And another is 4 plus 2 cycloaddition reaction, popularly known as Diels-Alder reaction. That is 4 plus 2 cycloaddition reaction, thermally induced. Here also loss of two pi bond, so only one pi bond you can see in the product. The third example of pericyclic reaction is sigma-tropic rearrangement reaction. So this reaction is an example of rearrangement reaction, and the definition lies in its name only. Sigma-tropic means there will be migration of sigma bond. So in sigma-tropic rearrangement, there will be migration of sigma bond from one end to another end of the pi electron system. It means your reactant is having pi bond system or pi electron system, and sigma bond will migrate from one end to its another end, and the total number of pi bonds will be same in the reactant as well as product. So number of pi bonds remains constant. The example I am showing here is that you can see 1,5 hydrogen shift sigma-tropic reaction. Moving forward, the fourth type of pericyclic reaction is group transfer reaction. In these reactions, one or more atom or group transfer from one molecule to another molecule. So there will be two reactant molecule will be there, and one group or atom will migrate or will transfer from one molecule to another molecule, and in product both molecule get connected through sigma bond. Very famous example is in reaction. You can see in the example how a hydrogen atom is transferred from one molecule to another molecule, and both molecule got connected by sigma bond. So here three important features that we will be discussing. The very first one is mode of activation. So a pericyclic reaction can be activated either by heat or by UV light. If the UV light activation is there, then we call it as photoinduction. Second important feature is the number of pi bonds or number of pi electrons involved in the reaction. It is also very important feature. And third important feature is stereochemistry of the reaction. Why these features are important in pericyclic reaction? These features are important because by changing either of these feature, we can change the stereochemistry of the reaction. Okay, how? That we will discuss in these three examples. You can see the first example is an example of 4 pi electrocyclic reactions, and second and third is an example of 6 pi electrocyclic reaction. The only difference between second and third reaction is the mode of activation. By changing the mode of activation, stereochemistry has been changed. By changing the number of pi bonds also from reaction 1 and 2, you can see that stereochemistry of reactant has been changed. You can see the relative stereochemistry of the reactant as well as product changing in the reaction. Now the important question arises, why it is happening so? Like why changing either the mode of activation or the number of pi bond involved in the reaction or the stereochemistry of the reaction, we are getting different results. Why it is so? Many reactions observed in this manner, and at that time that region behind that was unknown. Regarding the behavior of pericyclic reactions, multiple theories came in picture, such as conservation of orbital symmetry, FMO method. FMO means for intermolecular orbital method, Woodward-Hoffmann rule, and fourth is Huckel-Mobius method, HM method. So these four theories came in picture. Each pericyclic reaction we will be describing with the help of these four theories. So we will discuss every reaction in view of this theory. The basic introduction of pericyclic reactions is almost done, and after this we will be discussing our next topic, that is basic concepts related to pericyclic chemistry, and these concepts will help us to understand deeply about the behavior of pericyclic reactions. Thank you so much.